Let's talk now about definite integrals as an area of a region. So we need to stipulate if f is a continuous and non-negative on your closed interval a to b, then the area of a region bounded by the graph of f, the x-axis, and the vertical lines x equal a and x equals b is given by the definite integral from a to b of f of x dx. So it's very important that this has to be continuous and non-negative. Then the definite integral on the interval gives you the area. Okay, so it is the limit of the Riemann sum for any partition of f. So here, write the area of the region bounded by the graph of f of x and the x-axis on the intervals shown using a definite integral. Okay, so first we want our limits of integration here. So this is going to be from 0 to 4, so the definite integral from 0 to 4 of our function 4x minus x squared with respect to x. Okay? And that's all we have to do. Now notice this was non-negative on the interval, so this actually will give us the area that we're looking for. Now in example 4, it says sketch the region corresponding to each definite integral, then evaluate each integral using a geometric formula. Okay, so we know that this is going to go from 1 to 3, so from here to here, and it's going to be of the function 4. Well, that's just a horizontal line. Okay, so you can evaluate this definite integral by finding this area, and we can use geometric formulas to do this. And this is a rectangle, okay, and so it's just going to be 4 times 2, and so this area is 8, meaning this definite integral is 8. Now our next one goes from 0 to 3, and that's going to be of x plus 2. So let's plot the function x plus 2. So it's going to start at 2 and it's going to go up, rise over run, right, up 1 over 1. Okay, so there is our function, and it's going to be bounded by the vertical lines x equals 0 and x equals 3 and the x-axis. And now we're looking for this area. And this is a trapezoid. And we'll recall that the area here is 1/2 b1 plus b2 times the height. Now notice it switches a little bit. We're going to call this a base, and then this one's going to be a base, and then the height is going to be right here. So here the area is going to be 1/2 times, well, this height gives us 5, and then the other base here was 2, and then the height is the difference in the interval, which is just 3, and so this area looks like 7 times 3, 21 over 2. Okay, so the definite integral from 0 to 3 of x plus 2 dx is 21 over 2. Alright, let's try our next one. So here we're going from -2 up to 2 of the square root of 4 minus x squared. Okay, well, we know here that if y equals the square root of 4 minus x squared, if we squared this, we would have y squared equals 4 minus x squared. And we add x squared to the other side, so x squared plus y squared equals 4. Hey, we have a circle, okay, where the radius is 2 and the center is at 0, 0. So there's the center and 2 for our radius. Okay, so we're going to try to find this area. Well, this is a semicircle, so your area is going to be 1/2 times pi r squared. So it's half area of a circle. Now r in this case was 2, so the area is going to be 1/2 pi times 2 squared. So that's going to be 4 times a half, or 2 pi. And so we know the definite integral from negative 2 to 2 of the square root of 4 minus x squared equals 2 pi. All right, so that's how you can find definite integrals using geometric formula.